on the back of page 3. The front yesterday, we started some basic stuff with equations, variables on both sides. A couple of you got to the point that you even were dealing with, hey, what happens if all my variables disappear? This is kind of weird. We're going to actually touch on those special cases today. We hadn't yet yesterday, so we'll kind of see how that's going. But what we're going to do here at the start is deal with a couple of kind of yucky situations and then clean a few things up. And I'll mention it one last time as we get started. We're going to start with number 10. We're going to jump in with 2 feet. If there's ever an example I don't do that you either would like me to or you would just want to see it worked out, I have my notes online that literally are every single problem totally worked out. So you always are going to have that as an option. Okay, let's get down to business. Ugh, that's not fun. Okay, first things first. From yesterday, we discussed that if there's parentheses, we always need to do that first. So, quick reminder on fractions with these calculators. If you're going to do fractions, all we're going to do is put them in parentheses, and we're just going to use the divide button. I don't have a fraction button here. So 9/8 times 4. That's my first one. We don't like decimals either. So we also mentioned yesterday, and hopefully wrote down in the examples, that if we hit the math button here below alpha and enter twice, that will get us the simplest version of that fraction. The calculator really can be helpful. So I do it again to the next one. 9 divided by 8 in parentheses. Hardy, do I put it as -1/2 or 1/2? Either works as long as you remember that it's there. I like to put the negative in with it. So -1/2. Decimals, drat. Math, enter. Minus, or negative, 9/16. Don't lose your variable. We can't put them in the calculator, but I still have to have it as part of my equation here. And then we're going to do that one more time here on the right side. I know it's kind of a pain when you're typing all this stuff in, but man, is it better than having to deal with common denominators and doing it manually? Lot better here. One last time. 3 times 5/2. Decimal. Okay. Yuck. That doesn't look a whole lot better than when we started. So now what? Okay. We're going to simplify this. Most of the time, what we would be doing here is multiplying by something called an LCM, a least common multiple, which most of the time would then mean we'd have to make a list of numbers, multiples of 2, multiples of 4, multiples of 16, or do all that in our head to find the smallest one that they all have in common. Now, some of you may be able to rock that out and nail it right away. And if you can, that would make for the smallest numbers. But if you can't, here's what we're going to do. Every number you see in the denominator that's different. So I see 2, I see 16, I see 4. I don't need to do repeats, okay? I'm going to multiply those together. So I'm going to make a little note over here. We're going to multiply the denominators. So I'm just going to do those 3, because those are the 3 different ones. Oops, crap, I did the wrong ones. These 3, sorry, make an arrow. And we're going to multiply. Now, you're going to think this is going to be awful at the start. It is not. We're going to multiply this equation through by this 128. Well, why would I want to do that? Because it's going to wipe out all the fractions. After this step, there will be no fractions left anywhere, which is the goal. So, and I know how quick some of you are with your fingers already. I'm just saying, because I know how some of you on phones and texts that you'd be quick. So check it out. 128 times 9 halves. 576. No more fraction. 128 times negative 960. Oops, too many parentheses. Hang on a minute. Okay, we're just taking the fraction part in parentheses. Still there. Multiply by the fraction. I'll even show you one more option here. If you don't want to play it this way, and sometimes people like my alternate. Sometimes they do. Sometimes they don't. We'll see. Oof, that's some big numbers. So, Mr. H, if I don't like playing the fraction game, what's this other option that you're talking about? Okay? When you're doing this, when you're multiplying by a fraction, here's what you're doing in reality. You're taking this number, you're multiplying it by the number on top, numerator, and you're dividing it by the number at the bottom. Let me show you. 128, if I did it that way, times 9, divided by 2. That's where the 576 is coming from. If I do it here, 128 times negative 9, divided by 16. That's where the negative 72 is coming from. So whether you just multiply by the fractions, or you multiply by the top and divide by the bottom, they both work. So, but now, shoot, this just got a lot easier, because now, okay, let's get all our A's to one side. I'm a positive person, so I'm going to make sure my A's are positive. If you wanted to minus the 96A, you could. I still got to learn to write smaller. I'm going to keep saying that every day until I remember. 96 plus 72. 168A plus 960. All my A's are together. Next job, get my A's by themselves. So we're going to minus, or do the opposite of this, plus 960. It's a little bit of a chunker of a problem here. 68A equals negative 384. Oofda. Divide to finish. All right. Luckily, we don't have any problems that are this big. And of course it's a decimal. A equals negative 16 over 7. Like I said, do we run into that very often? No, thank goodness. But when we do, we got to be ready. Okay? It really is just the opposites that we're working to get there. But unfortunately, that one was kind of yucky. It happens. That's why we have this stuff on separate days. Okay. This is the one some of you ran into yesterday. These are going to be normal as far as not crazy fractions, crazy decimals, things like that. So we're going to multiply through by our 5 first. Make sure it's to both terms. Don't get lost with that. Also, that 5 is not going out here to the end of the 8C. That's off on its own. And so yesterday, once we did distributing, we said, hey, we've got to check to see if there's like terms on either side. If there are on the same side of the equals, we just put them together. Not opposites, like it's on the opposite side. So negative 5 plus 8 is 3. And now I'm going to get into a little bit of a situation. When I go to try and get my C's together, they all went away. When all your variables go away, I've got to check to see if the statement that's left is true or not. 1 does not equal 5. So in this case, when my variables all went away, there's no solution. Now, does that mean every time your variables all go away, it's no solution? No. Example. I multiply my -8 through here. I start trying to do my thing because at this point I've done this quite a bit. So I'm starting to feel confident that I'm going well. And I'm like, all right, so we got a plus 8x. Ooh, it happened again. But this time, 40 does equal 40. That's true. So there's a few ways you can write this answer. Typically in here, we're going to write it as all reals. You could write it as infinite solutions. That's another option you have. That just basically says whatever value works for x in both of these, every single one's going to work. It doesn't matter what number you plug in for x, it's going to be true. So just because the variable goes away does not mean you can't finish it. It's just going to be a special case. I'm going to skip 13 for the moment because I think 14 is going to give us everything we need. Whenever you're doing proportions, if you see plus or minus with anything, put parentheses around it right away if I didn't do it for you. Because that's going to keep you out of trouble. Because then when we cross multiply, I'm even going to write that over here. Then when you go to cross multiply and you go to write up your problem to set it up, you're not just going to multiply the 10 to the 2 or the 8 to the 5. You're going to multiply it to everything because you see parentheses and you know you've got to distribute then. So we got a little distributing to do. That's why we don't have a lot of problems on the practice. Because some of these are chunky enough as it is without piling on here. So distributes just multiply. And now the same as we've been doing on everything else. Got to get the x's all to one side. So again, I could minus 20 this way. I can minus 40 this way. It does not matter. I will end up with the same answer at the end. Ultimate test in patience when you're doing these. All my x's are together. Now I want them alone. Not even going to say what I'm thinking right now. Divide to get to our solution. Is that as simple as that gets? I want to say no. Nope. Always want to get to the simplest form. So keep these handy as you're doing the practice to make sure we get you to the right spot. Okay, I'm looking to see which ones of these we need to do because I don't think it's going to be all of them. Okay, let's roll with those. Okay, last thing is called a literal equation, which is a fancy way of saying you're going to solve an equation like you do for anything else, except there's going to be a whole lot of variables involved. Ugh. Not as much fun, but something we can deal with. So, you'll be told what variable you're solving for. Of course, pi is right in the middle of all this, so I'm going to try and box that in. So here's what you've got to think about. What am I doing to pi? I'm multiplying it by 2 and r, because that says 2 times pi times r. Well, if I'm multiplying by 2 and r, what's the opposite of multiplying? Dividing. So we're going to divide by the stuff that's not pi, the 2 and the r. So on this side, all I got left is pi. And over here, you're kind of looking at it, and you're like, c divided by 2r, what do I do with that? Nothing. Pi is by itself. I've solved for pi. If you remember from geometry, this is the circumference formula. And if I wanted to be able to know, how is pi derived? You just take the circumference, the area around the circle, and divide it by 2 times the radius. It works every time. It's kind of cool. And so, as we try all these, we got to keep reminding ourselves, okay, what do I have to do to get this particular piece by itself? If there's a fraction, I'm dividing it by c. Okay, what's the opposite of dividing by c? Multiply by c. Whatever we do to one side, we do to both. Over here, the c just makes the c in the denominator go away. This is always one of those parts of the notes that people are doing the practice. They're like, Hardy, I don't get it. It's not you don't get it. It just looks weird. Solve for b. I'm adding a to it. I see it right there. What's the opposite of adding a to it? Subtract a. Answer's going to look weird, but it's going to be right. B is now by itself. 5c minus a. I'm done. It is very, very strange when we do these, but hey, it is what it is. I'm actually going to go past 18. I want to go to 19. We'll come back if we need to. Ooh, solve for v. Okay, follow the rules. Distribute first. So 1/2 goes to the w, 1/2 goes to the v. Now fractions, we just dealt with this up in number 10. Oh my gosh, it's not going to be number 10, is it? No. No. I can still take my denominators and multiply to make those go away. I don't even think we need the calculator for this. 4 times 7 is 28. What's half of 4? 2. Now, parentheses are out of the way. Fractions are out of the way. There's my goal now. We got to get the v term by itself. I'm adding 2w to it. Do the opposite. And this time we're even fortunate enough. These are like terms. I got 28 w's. I take 2 away. I got 26. And to get v alone at the end, I'm multiplying by 2. We're going to divide by 2. Just keep reminding yourself, it's all about getting the variable by itself, and that's it, okay? Your answer can have variables. So last one, before I let you loose for your monstrous 8 problems here. I see parentheses again, we're going to fix that. So 180 times each of these. Parentheses are gone, no fractions for once, hallelujah. My goal is to get n by itself. Just keep doing opposites. Opposite of minusing 360. Okay, now here, notice, I didn't say it was 360s. I'm not multiplying them. I'm just adding them together. And then again, we want to get n by itself. What am I doing to it? That's always the question. I'm multiplying it. So we're going to divide here at the end. Can I get a big old fraction as my answer? I can't. And we're set. Could I reduce that more? Maybe. I could do the 360 divided by 180, but I'm fine with you just getting it there. I'm perfectly content with that. So, here's the initial game plan. If we need to adjust, if some of you need me to do some other ones, I'm perfectly willing. So, we're back in the practice now over here. We did page 3 yesterday, or at least we were supposed to. Today, the game plan is to try out page 4, getting some of the fractions, getting some of the proportions, getting some of the things like that, reminding myself to put parentheses around some of this stuff before I get in too far. But as long as you stay on top of the practice as you go and don't put it off, whether it's you don't want to, you're not getting things, ask questions and keep going. Because that's going to put you in a better spot at the beginning and not playing catch up from the start. So